Hello, and in this video we're going to be looking at graphing some transformed logarithmic equations, meaning that we're going to move them left and right, up and down based upon our transformations. They're going to be like our polynomial ones that we translated, or quadratics, power functions, all of those functions that we translated earlier in previous sections. We're going to do that with logarithmic functions as well. So we're going to transform them and move them about. So we're going to start off with the domain of a logarithmic function. We're going to start with that so that we know where we're going to be graphing from. Now, the domain of any logarithm f of x with log base a is always going to be greater than 0. So we're going to have a domain that's always greater than 0 in any logarithm with this x value here. We can only evaluate positive values in logarithms. If we try to take a log of a negative value, if we say log, in this case, log of -5, it's going to tell us that we can't do that in our calculator. It's going to say we can't evaluate negative numbers. We can't even evaluate 0. If we try to take the log of 0, well, we have to quit here. If we try to take the log of 0, we can't even do that. It has to be positive, right? It has to be positive values. All right, so I have two examples here of where we're going to find the domain of each logarithmic function. These are transformed functions. We're going to look at their domains. So in this case, we want to make sure that this logarithm, this value is greater than 0 or positive. So we're going to say x minus 2 is greater than 0, and we're going to say that x is going to be, by adding 2 to both sides, x is greater than 2 is our domain. And we will write that from 2 to infinity. So that's the domain of this function, this logarithmic function. We have to look at this value and see where it's positive. Alright, so we do the same thing on this second example. We would look at where this function is positive. So we would write 4x plus 5 has to be positive, and we'd solve. So we get 4x is greater than -5, and then we divide and we get -5/4. So x has to be greater than -5/4, or your interval would be -5/4. Oops, -5/4. To infinity. Okay, this would be your domain of the second function. Now we're going to look at graphing those transformations after we've done that. So we're going to look at this graph right here as my example. We're going to sketch log base 2 of x minus 3 minus 2. So this should transform the graph to the right 3 units. It's a horizontal transformation. This should shift it down. Sorry, yes, this is down 2 units. It's a vertical shift up and down. So what we're going to do is we're going to try to graph this. Since we have log base 2, we're going to have to look at its basic function. Its basic function is log base 2. All right. Now, in order to graph the log base 2, what we're going to really do here is we're going to use the inverse. We're going to use the inverse, which is y equals 2 to the x. So we're going to try using those values, and then we're just going to swap them. So over here on this side, I'm going to make a chart of values for x and y. We're going to use 2 to the x here as our inverse function, and then when we graph these, we're going to graph them, this is an x value, this is a y. We're going to swap them around. So I'm just going to start off with my basic numbers. I always like to start off with -3 and go to +3 when we're trying to graph something that's near the origin here. So we're going to raise it to this third power and then take the reciprocal. So 2 to the third is 8, and we take the reciprocal of that and get 1/8. 2 to the second is 4. We take the reciprocal of that as 1/4. 2 to the first is 2. Reciprocal of that is 1/2. Anything to the 0 power is 1. This would be 2. 2 to the second is 4, and 2 to the third is 8. So these would be my values, but we want to swap these values. These are going to become my x's in logarithm, and these are going to become my y's. So let's just graph a couple of these. We can let's do this one. 1/2 -1. It's right here. 1/2 -1. 1/4 -2. Get that one as well. We can't get this one. We don't have a 1/8 on the mark, but we got these two. 1 0 1 0. Reading it backwards. 1 0 2 1 2 1. Reading it backwards. 4 2 4 2. And 8 3 8 3. Okay, so this would be my function of y equals log base 2 of x. So that's my basic function. So from my basic function, I have to do these transformations. So I'm going to move it to the right 3 units. That means I'm going to move this asymptote right here. My asymptote was at x equals 0. We're going to have to move it to the right 3 units. So now my asymptote is going to be at 3. So here's my new asymptote for my new function at x equals 3 is going to be my new asymptote. So I'm going to take these values now and move them over to the right 3 and then down 2. So if we take this value right here, move it over right 3, that would take it here and then down 2, so that's going to go down to -4 right here. So that's my first point. That would be this point. Now my second point is 1/2 -1, so I'm going to move over here 3 units and then down 2. 1 2. So it end up right here. And then this point is at 0, so we're going to move it over 3 units and then down 2. 1 2, so it goes through right there at 4 -2. And then this point here is 2. We're going to move it over 3 units. 1 2 3, and then down 2. 1 2 down. Goes through this point. And then we'll move this point over 3. 1 2 3, and down 2. 1 2. It's going to go through the axis there. And then this is my last point. We're going to go down 2, or over 3. 1 2 3, and then down 2. 1 2. Goes through there. So my graph is going to look like this. Shifted graph. So this is going to be my f of x equals log base 2 of x minus 3 minus 2. I just shifted all my points that I had from the chart here. I shifted them right 3 and then down 2. It's domain is from 3 to infinity, and it has a intercept at 7, 0. 7, 0 is my intercept. Okay. We go to infinity as it goes to the right, and it has an asymptote to negative infinity as we approach 3 from the right-hand side. So that's how I would graph a transformation. Graph the inverse, swap the points, and then move them based upon the graph.